upcoming events. It's the Cloud Natives, the Oakland Cloud Native Lab is part of the CNCF community. So those that probably are not very familiar with CNCF, so CNCF is the organization that basically is the home for this kind of concerning number of projects, open source projects. So it's growing for years. So, and basically CNCF it's supporting the open source community in terms of guidance, in terms of governance, in terms of connecting opportunities, supporting developers, and supporting the community. So in cncf.io, so you can find more information. But yeah, so hopefully now, so most of you are already know what organization is doing to the global level. One of the activities that CNCF run, ambassador program, basically it's a community of leaders that I feel that at the moment it's around 200, 250 around the world. And yeah, basically the program is to promote people to be involved on the project and support the rest of the community. So there are multiple projects running at the same time, so which are supporting technical work for people who want to kind of contribute to open source, but there is also a kind of support for people who are interested from the community perspective in terms of supporting mentoring, supporting community initiatives, documentation, and whatever other activities that could be happening on the technical side and on the community. So yeah, at the moment, there is an application for the upcoming group of ambassadors. So if you in learning more, so you can go to CNCF and this initiative of CNCF ambassador. Since last year, so I'm one of the two Cloud Native ambassadors here in New Zealand. So if you have any, my particular experience was more about being involved in community for the past 12 years. So that's basically what brings me to this CNCF, and that was my motivation in terms of being involved with CNCF and supporting the ambassador program. So if you have any questions or you have any ideas that you would like to contribute, or you need support in any way in terms of what there is happening on the CNCF, feel free to connect with me, and yeah, I will try to for as much as I can. One of the activities that CNCF ran, it's a conference, big conferences. So the next one is in Paris. So if you want to go to the other side of the world, next month. Yeah, so KubeCon Paris is happening in mid-March. It's a 10K attendees, so there are massive conferences. So every year they have a scholarship program. So probably for this one it's too late, but so for the upcoming, so you can apply for those scholarships and they support financially in terms of for you to attend the conference, and sometimes that money helps to pay tickets, and registration is also always quite covered by the scholarship. So yeah, you are more than welcome to explore more about this. One of the interesting initiatives around this conference is Cube Train, which is a project that one of the ambassadors is running. And basically, every KubeCon, so he organized travel around the region, going by train to the conference. And it's a really good experience for connecting with community. And if one day you have the opportunity to attend one of these conferences, so yeah, I strongly suggest to this. More in the local kind of space. In Wellington, for the past 5 years, we have been running a Cloud Native Summit, which is probably a smaller conference, but still very interesting in the native platform engineering topics and DevOps and software development. So yeah, so we still don't have date for this year, but yeah, keep an eye to this if you're interested in attending a very accessible conference in New Zealand. And yeah, so last but not least, the two speakers for tonight. So we have Jonas Felix and Marcel Medina. Jonas is coming from Europe, so yeah, thank you very much for and Marcel, yeah, so Marcel, it's here, so it's he's the local speaker tonight. So yeah. That's all from my side. So if you have any question about anything, so CNCF or any other activities or anything else happening on the meetups, yeah, feel free to reach out to myself. So thank you very much, and thank you very much to everyone attending online as well. So yeah, that's all from my side. Thank you.
Hello. Does this work? Everybody? Oh, yes, I hear myself. Yeah. It works. Perfect. So I will try something new in a talk. I do this during trainings, especially if I do hybrid trainings. But this is the first time I do this in a talk, because talks have more time pressure. Okay, let's see if this works. Does this work? Yeah, it works. Okay. So hello, my name is Jonas. This is me. And I came all the way to New Zealand for the talk. And also to start our subsidiary in New Zealand of Let's Boot. So we are from Switzerland. Actually, Barbara and me started the company about 10 years ago. And in Switzerland, we have about 10 trainers, 30 trainers, sorry. And yes, and we really like New Zealand. So that's why we're here. We really love it. If I'm allowed to do a small shout out, we have a public course on the 4th and 5th of March about Kubernetes in Auckland. So if you want to come, convince your company to send you, just as a quick shout out. But I don't want to bore you too much with us. I want to talk about some other topics. I would like to talk about Argo CD today, which in my opinion combines two other things. And one thing is GitOps. You will see later what I mean with GitOps, and the CD part in CI. So these are some of the topics we look at. We'll for sure do hands-on. So you only have to endure those slides for about 10-15 minutes if I'm on time, and then the rest I will do hands-on demo. I will talk a bit about Helm charts, but no worry, I will not explain the syntax. I will maybe even talk a little bit about some patterns like app of apps, of course, what is an application in the context of Argo CD. And you maybe recognize that this UI part here is not really a strong color, and you will see later why that is the case. So first of all, I want to get everybody on board to what we want to talk about. As I described in the meetup, I want to make it, if I can, as smooth as possible for everybody. So we're concerned about the century-old issue of how do we get our code somewhere so someone else can use our app and update it regularly. So this is actually what we want to do. So we have our code, and we have some users, usually in between we have some servers, and somehow we need to get our application there. So if we want to get our application somewhere. Today, there is kind of like a pretty straightforward way to do this. We have our code, and we build it depending on the technology we use. So we get our compiled app, and our application usually needs some environment, which are dependencies, libraries, runtimes, whatever your technology stack programming language requires. This can be very fancy with Golang, where you have kind of like empty, just one binary, or it can be nearly complete server operating system. So we want to package our application, and we want to run it usually on a server. And spoiler alert, even if it's serverless, there's still a server somewhere. And we want to run the application isolated. I should laugh about my own joke, but I'm not a stand-up comedian. Okay, minimal overhead and reproducible. And the reproducible part is really important. So this is something I want to talk about a lot today. So there is no surprise. We have a technology for that, which is kind of like taking over nearly everything, which is called containers, which is basically everything our application needs to run, including the application, put in a package, which we call a container image. And then we need some helper to make this thing run. But now the most important part about containers, and I like to repeat this all the time because there are some misconceptions, is we have an operating system that can already do everything we need. So the Linux kernel is extremely powerful for many, many, many years. You can also do it on Windows, by the way. We did some Windows containers for the military last year, but you will probably never see any Windows containers. It will be mostly Linux containers. Long story short, the Linux kernel or operating system kernel can already run application isolated with separate file systems, separate process views, separate network. So it feels like a virtual machine without running a virtual machine. So why do we need this thing? We need this thing because we need to tell the operating system what we want to run. We need to start it, and we need to get and build those images. And this helper, because naming is really hard, is called container runtime. So the container runtime basically takes an image and starts, unpacks it and tells the operating system how to configure this isolation, and then starts your application in there. And the most common one for sure is Docker. Docker wasn't the first, but it was the one which made everything smooth and taking over the world. So it's an Argo CD talk, I know, bear with me. So we come to the next step. We have our applications, and we know how to package them reproducibly and put them reliably on a server and run them. But usually we do not only have one of those, we have usually multiple of those. And usually we even have multiple servers. And if we are super cool, we even have a dynamic amount of servers. So sometimes we have more servers or less servers, depending on how much we like to pay to the big companies, or how much resources we need. So we want to go reproducible again. And if we want to go reproducible, we want to describe which containers should run and how they should be able to run together, what they need. Maybe, I don't know, universe forbids, somebody needs a disk, or there should be some network rules or whatsoever. There's so many things you can or want to configure or don't want to configure, but have to configure and so on. So for this topic, we have something called orchestration. And the absolute go-to tool is Kubernetes. I mean, to be honest, the cloud native computing foundations somehow started with Kubernetes. They were forward-looking to call themselves cloud native computing foundation, but I think it's the main and only more or less only remaining orchestration solution out there. Most other solutions build on it. But that's not the topic of today. The topic is we want to define in our manifest what should run. We want to hand this to Kubernetes and hope that Kubernetes does more or less what we want it to do. We still have to give Kubernetes these files or those files to make this run. And an important thing to know about Kubernetes is where is the value in our work? Is it on the servers or is it in the manifest? It's a kind of a rhetorical question because the important part is the manifest. It's the manifest and it's the, oh, this next slide, Docker file which creates the image, our code, and so on. So this is actually the value. So there it is. There it is. So we define orchestration. We write our code sometimes. Besides site reliability and DevOps and GitOps and whatever we have to do, we still have to somehow, some people still have to write code. We write Docker files to build images, and those are the things which are actually important. The cool thing is, if you have those, you can do this again and again and again. And the easier and faster you can do that, the easier and faster you can iterate and innovate. So everything you have in a file, you can change the file and then throw away everything and start it again, or update it and check if it does what you want. The easier it is to basically improve. So now we have this funny topic called CI/CD, continuous integration and continuous delivery or continuous deployment. And these CI/CD pipelines are usually automation steps which do things to make sure that the changes we do work together, work at all, and with the CD part even get to some system to run for our users. So if we have the most minimal CI/CD pipeline, we have a step which builds our image and puts it in a registry, and we have a step which applies our manifest to the Kubernetes cluster. The coolest, most fancy solution at the end does these two steps. It's just a lot of other cool steps you maybe put in between and some fancy syntax and tooling you put around. At the end, those are the two core steps. And one of the harder parts, maybe some of you know that, is kind of like how do you agree on versioning and how does this and this then relate to the same version, but that's another topic. Okay, so the tricky part, now I get to my topic and then I will go hands-on, is CD can be tough. It depends, of course, on the complexity of the project and on the complexity of the infrastructure, but CD can get continuous delivery, continuous deployment can get complex, especially if you go on different environments, if you go on production, if you have many different depending applications, and even if you have different teams with different roles and so on. And some of the topics which are hard is like keeping track, just keeping track which state is on which environment, which cluster runs which orchestration. Then also, if you do everything on your own, concurrency can become an issue after some time. Like what happens if one pipeline overtakes the other? What happens if a pipeline fails? Where do you roll back to? Do you even roll back? Everything can be solved. I mean, we can solve everything. That's not the point, but it gets complex. And then also, they're like those guys, that can be me. To be honest, there are people who generate drift, who do something at the cluster, which is not represented in our manifest. And that's dangerous, because as long as we don't have to recreate our stuff, or as long as what we changed on the cluster didn't hurt anybody, it's okay. But at some point, maybe this change that we did directly, this drift we generated for whatever reason, can bite us. And usually it's when we're at home with the kids on the weekend and we get these calls and somebody changed something in the cluster 3 months ago, nobody knew it, and the next deployment crashed everything. So now here we go with Argo CD, which should make everything simple about the CD part, or should allow you to simplify the CD part. The core concept of Argo CD, and that's what I want to focus on, is you have Argo CD usually running in your Kubernetes cluster. Of course, it can manage multiple Kubernetes clusters. It can be software as a service. Everything is possible. As you know from the Kubernetes ecosystem, you can do everything the way you want and a bit different and whatever. So Argo CD usually runs in your cluster, and Argo CD is really good at knowing what happens in the cluster. You tell Argo CD what application you want to have continuously delivered to your cluster. And you tell it by telling it where those manifests are. And they are usually in a Git repository. And there comes the name GitOps. So we have this single source of truth. It's a Git repository. We have commits. We can do merge requests. We know who committed and pushed whatever. So we have a good way to track and manage changes. And then Argo CD basically listens for that and realizes that. So much to that. Now, let's. Yeah, okay, I will try to work with that. So good, okay. So we're here in a lab environment. We have a lot of different courses with different, like in-person courses with different requirements. So we invest a lot of time in our lab machine. This is our Argo CD lab machine. It basically is started from a GitLab CI job and gives you a code server and Argo CD login, ingress, and everything. It's quite powerful clusters you get, and you can start and stop them anytime when you need them during the training. So where am I? I am here in a Git repository.
Sorry, Jonas. Yeah. Is it possible to make the text a little bit bigger?
Oh, yes, of course. Yes. Is this good? Okay. So we're here in a GitLab project, which is, if you don't know or use GitLab, it's for this course, it's basically just a Git repository. And I put several things into the same repository just to make the demo a bit simpler. So we have here a little web application or website, which we put in a container. We have some CI/CD configuration, and we have here the magic GitOps part to show what I want to show. So I'll go into my lab environment. This is just the Visual Studio Code running in my browser. And because I can get nervous, I have my cheat sheet up here. And
can you zoom in again? Sorry.
Yes, of course. Of course. How's this? Okay. So let's just quickly check where we are. We're here in a lab machine. We have Visual Studio Code. We have all commands installed, and we are authenticated, so we can talk to our cluster. We can look at the nodes. We have a 3-node cluster. We can look at the namespaces in Kubernetes, and you see we have here an Argo CD namespace, and in this Argo CD namespace in our Kubernetes clusters, there are the resources representing the whole Argo CD topic. If I look at the pods, just to give a quick overview without boring you too much about the details of Argo CD, we see here that we have pods, or if you're not too much into Kubernetes, it's more or less a container. And if we look at this, we have here the application controller, the application set controller. Those two containers manage applications and application sets, which are resources, so-called custom resource definitions for Argo CD, which you can manage like all other Kubernetes-related resource. Then we have the repo pod, which is important to sync the Git repositories, and we have the core part of Argo CD. This is more or less what we have. Okay, so what do we do now? I have a very simple application here, just as a demo situation here in this folder, Argo CD deploy, Caddy. Caddy is just a very simple Go-based web server. So I have here this deployment resource. It's a typical Kubernetes resource. It will take care of having 2 pods run at all time. And these are the templates for the configuration of the pods. So the pods will run a Caddy image as a container. So there will be 2 Caddy web servers running. And because I want to talk to them, I need something in between. And this something in between is called a Kubernetes service. And a Kubernetes service basically bundles those containers behind a DNS entry and an IP address. So we have load balancing and failover and so on. And because I want to be very cool and even make it available outside, I have here a small ingress configuration which will tell Kubernetes to expose this through so-called ingress controller. So these are the manifests. These are the manifests I built, and of course I can just apply them manually here to my cluster, and it's just kubectl apply, and then I can check if they run, and we see here that we have here the caddy running. I need to do some cleanup work, just a second. That's like always. Yeah, I will do this later. I'll do this later. If you don't, yeah, perfect. So the caddy works, and we can even open it. So here we can open it. This is our caddy, and to prove it that our caddy is basically simple, I just delete it. Let's delete it, and here caddy works, and here caddy doesn't work. So this is our caddy. Okay. So now this is boring. Let's go to Argo CD. So I was talking about GitOps and having reproducible ways to track and create things and recreate things. So what I of course want to do first is I want to go into the UI. I know I have to zoom in, sorry. And now here, of course, I have the Argo CD UI, and now I go to create app and do a lot of settings, and probably not the best way. Probably not the best way. So I think this joke didn't work out as I planned. So what am I doing? I was talking about reproducibility, manifests, GitOps, trackability, and so on. And now I go into a Argo CD UI, and I create some meta information which will be stored somewhere. I mean, I know where it's stored. It's stored as a Kubernetes resource type application in etcd and so on. I know how to manage that, but still, like, I don't want to use the GUI to configure it, because otherwise I have to do screenshots in a Word file and describe first, click here, second, click here, and that's a way to do something. Sometimes you have to do this, but in this case we don't want to. So what I want to do is actually to say, okay, this GUI is very powerful, as you see later on, but I want to stick to the simple things, and I want to simplify things. So let's go a step back. What we actually want to have is this. We want to have Argo CD creating our Kubernetes resources and managing them, that they're always in sync with our Git repos, with our manifests in our Git repos, which is here. This is Git repo. Okay, so first we have to tell Argo CD about the repository. I put the command in there if somebody wants to retry this exercise at home, but I already prepared this. So if I go here, I can look at this repository. So I told Argo CD, this is a Git repository I want to use. I can add as many Git repositories as I want, and then Argo CD will fetch them frequently and check for changes. Of course, I can look also at them in the GUI. One little thing I want to mention here is Argo CD really tries to be Kubernetes native. So here also this repository is actually a secret. So if you look into this, you will see that in the Argo CD namespace, you got a secret or multiple secrets with this funny label, Argo CD secret type repository. And then you actually see the configuration here represented in the data. So we could theoretically just create this from YAML file, but I don't want to put my passwords of my tokens into the Git. That's a whole other topic. Okay, so let's go back. Now, what I wanted to show you is we want to do everything with configuration and reproducible. So we have here this app of apps folder. And in here we have this caddy app YAML, which is one of those YAML files again. And here we see it's a regular Kubernetes resource. From the structure is like a regular Kubernetes resource with spec, metadata, kind, API version. And here we have this kind application, and the API version is related to this Argo project. And here we have this specific configuration. So this is a very minimal one, of course, but it's the most important things you have to know. So we have a destination. And because this Argo CD serves its own cluster, we have just the cluster it's running on. And for now, we just work with the default namespace. And we have a source, which in this case is a Git repository, because we want to do GitOps, and a folder. So if you see, this is the Git repo of this project, and here Argo CD deploy caddy. You see, this is the manifest I just manually applied. Okay. So now what I can do is I can use the tools that I'm used to use, which is kubectl apply. And I can just say app of apps, and then caddy app, and then bam, it gets the information from the Git repository. And now the UI is powerful. That's a cool again about Argo CD, is really to look at what's working. It has a hard time, I think, with this zoom level. We don't have to read everything, just more or less follow the green color. So sync, okay. There's stuff flying around that looks green. Progressing, it's not 100% happy about the status of the ingress, but we live with that for now. And now we can even open this caddy again, and this is the caddy that was deployed by Argo CD. Now let's do some GitOps. If I go into this folder here, Argo CD deploy caddy, I go to my deployment and I do replicas 4, and then I have my Git. This is not Kubernetes related, changing YAML file, committing stuff to Git. It's like very basic tooling we use usually every day. And now we can say GitOpsing the replicas up for the meetup rush. Okay, and then we can synchronize that. And now we have here our Git repository, and we see here, this is my commit. And now it's up for Argo CD to grab this. So in general, Argo CD does like a pull every several minutes. You can also configure webhooks. So your Git solution tells Argo CD, hey, you should refresh the Git repository. So that's up to you if you're willing to wait a few minutes, or if you want to configure your Git solution to tell Argo CD. Or something I actually don't like to do, but during the talk I will do it now. It's usually much cooler if it happens automatically, but I don't want you to wait 2 minutes. I would just press refresh. Refresh will basically just trigger this Git fetch. And I really, really promise you, if we all wait 4 or 5 minutes or 3, it's actually 3 minutes, I think, there will be those 4 replicas. You see, now we have more replicas. So we can actually now see that something changed, and we can have here everything tracked in a Git. And it's super simple, that's it. That's it. Now we can add YAML files, we can add all kinds of things. Most of the core topics are solved. Argo CD watches our Git repository, and if something changes, it tries to synchronize it. And now we have all the tools of Git. We can do branches, we can do merge requests, we can do reviews, we can do different environments, and so on. Okay. There are some other things, of course, we get with Argo CD if we want them. We do not always want them. So for example, what if we create drift? So imagine, for whatever reason, somebody deletes ingress caddy. Maybe they have some conflict with another ingress, and they're like, oh, I just delete that. And then they don't know where it was coming from. And the ingress resource is not like a pod, which is recreated because of the replica set, because of the deployment. The ingress resource, if you delete it, it's deleted. Kubernetes says, okay, let's delete it if you have the permission to do that. So let's do that. I added this command right after, like k-delete ingress caddy, and then k-get ingress to prove that it's actually deleted, because Argo CD is so fast, otherwise you won't see it. So you see, k-delete ingress said, okay, I deleted caddy ingress. K-get ingress immediately afterwards said there is no ingress resource, and k-get ingress will show us this ingress again. So this is basically preventing drift. You do not want to have this in every project. There are scenarios on production, depending on how you have your roles and so on, that you maybe cannot do this, but this is of course a recommended pattern. If you can start a new project, I would try to implement that from the beginning and try to make every decision that this works. But that's a complex thing, but it's really cool if you can manage to do it. So now let's remove that stuff just to make sure that we do not have any leftovers. So now everything is removed. And now just to do it, because it's so nice, just do it again. To do it again. This is what I mean with the reproducibility. You see, I deleted everything. I apply this app YAML again for Argo CD. Argo CD gets the newest version on our Git, and now it's running again. So this is basically the important part. Okay. Now let's go on. Now I was talking about CI/CD. For whatever reason, I put that in the talk description, so I have to show you some more things. So when we go here, we have this static site demo, which is a very complex application. It's just the index HTML, but it actually doesn't matter, because we just put something into a container and it should be available somewhere. There are no buttons, no database or anything. It's just a file served by a web server. And here I have the Docker file. So the reproducibility for the image is my index HTML and my Docker file. As long as I have those, I should more or less keep it reproducible. I know I shouldn't do this. I should do this. I know, but it's a talk. Okay, so this is a Docker file. This is my HTML file, and it basically puts my HTML file into a container with this base image where there is a web server included. I have here the steps to do this with Docker. If anybody wants to try it at home, for now, I will not bore you with the Docker steps, just to have you inspired for the CI part. So the most basic CI part for container is we need to do a Docker build, and then we need to push it somewhere. So let's look at the minimal CI/CD pipeline that I prepared. I use GitLab CI because I really like it. And it's really crude, I know, but that's what I like about it. So basically I have this GitLab CI, which includes my GitLab CI pipeline YAML, and in there I have the includes for the other parts of the pipeline, and one part is this build containers YAML, and in there I basically built this static site demo. This is the job that I actually will run in the pipeline. It's a really cool feature about GitLab CI/CD. It's GitLab CI/CD components, where you can build reproducible components. I don't get paid by GitLab in any way. I just like some stuff they do. Not everything they do, but some stuff I really like. So, but for you to better understand it, this is basically, or to make it easier to see what it does, it's basically logging into my registry where the image has to go, and building the image, and then pushing the image. So this is what this building container step does. And because you should not use Docker in the CI part to build containers and push them to a repository usually, especially at scale, If you want to know why, you can talk to me afterwards in the coffee. I like to use Canico. So what do I want to do? I want to build my container, and let's do this. So welcome Auckland, and then get my container built. Auckland. And now I will have here a nice pipeline. Which will build this container with Canico. So it's already done, 8 seconds. I mean, it's a simple container, but this is the first step in our CI/CD part. But now, how do I get this CI part to the CD part? Okay, so there is nothing here yet. There is our CI part from the pipeline. This is the application we changed. This is the CI step to build the Docker image. And now we just do what we did before. We add a Argo CD application to deploy to tell Argo CD that it should deploy this static site. Okay, I can quickly show you this here in the apps of apps up here. See here, static site demo. This is again an application resource. It deploys to our cluster. It takes it from our Git repository, and in this case, I even use a Helm chart. And because I use a Helm chart from my Git repository, I tell it what release name it uses. So I can install even several versions. If we would have more time, I could show you like how you do it with feature branches and so on, like even like shutting down everything after pull request is merged and so on. Okay, so this is the Helm chart it gets. It's also just a folder. And it's just a chart, our own little Helm chart, which basically Kubernetes manifests with a lot of funny curly braces. It's great to use. It's hard to write. Okay, let's go back. So actually, we have created this application here, static site main, and we have here our static site, and we can look at it. And we see, there is no welcome Auckland. So, okay, we built the container and we put it into the registry, and we told Argo CD that it should use the orchestration to put our application onto our cluster, but it's still not using the right version. And this is where CD comes to play. And this is a possible pattern to do it. It's not necessarily what you have to do, but if you want to combine your CI part of the pipeline, which can be super complex end-to-end test, integration tests whatsoever, to your CD pipeline with Argo CD, what you want to do is actually stick to the GitOps pattern and just change the thing in the GitOps that actually has to change because of the CI part, and what has to change is the image version. So we just changed the image version in the value file, and there is a commit message, and we will be able to know, okay, this image was changed because of this CI pipeline, which led to actually change the image version, if we want to go all the way CI/CD. Okay, I just activated this, and then now I can just say, go production. And now the pipeline will run again. It has another step. And container is built. And now basically if we look at this job, it basically does something really simple. It changes the version in the YAML file, and it pushes it to the Git repository. And then Argo CD takes over. And if the timing is right, but I was a bit too fast speaking now, it actually would happen now. But I don't want to let you wait, so I press refresh. So this would happen after 2 or 3 minutes anyway, and then you see the second replica set is created. So Kubernetes knows which version belongs to which replica set. The replica set will stay around for a while until it's cleaned up, but the new version should already be there. So if we go here, we have the welcome Auckland. And we can still do GitOps, so we can still like configure our orchestration and have Argo CD act on it, and we can still have our CI pipeline, which in the end wants to change the version of the image we want to use. That's kind of the thing. And one final thing I would like to show is now you say, okay, but I still somehow, now I have multiple teams, multiple applications, and so on. I still have to somehow apply those apps and those application YAML files. And if it's just one project, it's maybe okay, but as soon as it's growing, as soon as you have more complex structures of who's able to add a new project, you want to have a bit more of a tree structure, and you want to have a single entry point. So what there is it's a really cool pattern. Just make sure that everything is gone here. Okay, everything is gone. This should be gone. Okay. And this is the app of app pattern. So what I do is basically I say, hey, why don't we add this folder as an app? So we basically at one point have to apply one application manifest to Argo CD, and then something magical happens. Everything gets started up. So this root application refers to a folder with application resources which get delivered to the cluster by Argo CD, which then again go to Git repositories and get the orchestration and create those. And that gives us a really fun experiment we can do. I can take this MariaDB demo app, and I can just put it in here, in this folder. Imagine somebody can do that from another team, creates a merge request or pull request. Somebody who has the permission approves it. This is the, okay. Somebody approves it. I just had to pull first. And now we added this, and now here, if we refresh this root application, we get a MariaDB. So imagine you can structure Git repositories with the permission of your Git tool of whatever you like, and then have different repositories which give you this tree structure. So somebody could go there and say, I need something, some new project. You accept merge to pull request. Your root application picks it up and then adds it. So this is more or less that. There's many more things, of course, to think about. But that's actually the idea of GitOps with Argo CD. Basically, one YAML file to rule them all, and the rest you do with the tools you love, which is Git and whatever editor, if you like Nano, Vim, or Terminal, or whatever floats your boat. Where's my pet? Here. Oh, I hope it's still there. Yeah. So the conclusion for me is really important. Yes, Argo CD is an amazing GUI, and it has so many features. You can configure so many things and hooks and blah and blee and bloop. Don't start with that. Start with the most simple part. First, start with GitOps. That's really important. If you do not start with the GitOps pattern, it's really hard to go back. You can do Argo CD imperatively with commands and everything, or even with the UI. But if you then want to go to GitOps, that's hard. So start with GitOps first. If you start with that, everything else will be much easier along the way. And remember, it should simplify CD. So don't start to add features that you already don't have. Start to use it, start to simplify. Simplify means I have a lot of different steps, verifying and rolling back and CDA to me in my imperative CI pipeline, CD pipeline. I remove those, replace it with a Git repository and the Argo CD application, and then I work from there. I only add stuff I need. That's the important part if you start with Argo CD. And that's it, actually. So if you want to, if those lab machines are pretty powerful, so I cannot, and therefore our on-site training, so I cannot just give you a link and you can just log in. We have here a little form. So if you want to have this lab scenario on our lab machines, just fill in this form. And then we will set up an account on our GitLab, and we'll set up an Argo CD lab so you can play around. Yes, that's actually it. Thanks a lot. So I will hand over.
That's perfect. Nice. For the mic. Thank you.
Oh, yes. Ha.
Again.
All right. Well, nice to see the community just gathering here and well, see the number of people, right? Because in general, I think like there are some communities where you don't see a lot of engagement, but just happy just to come and be invited by Chris on this session. And let me just share my screen. So, all right. I just need to put like another connector in here, otherwise I'm not going to be able to share this screen, I guess. Just bear with me. I have all connectors in my bag because you never know. So like all the concepts that we have seen with Jonas presenting is going to be valid for what I'm sharing because I'm going to be talking about containers, right? Any developers in the room? Okay, yeah, no, pretty good. I guess like developers, DevOps people, will get to do similar things. We're doing scripting, we're doing coding, right? Let me share my screen here and bring that up. Oh, not that, the other screen. Let me revert. Okay, all right. So I bring like just a statement. It's not mine, but as you can see, like general purpose container images are not the future of cloud apps. Anyone agrees with that? All right. So maybe who disagrees? No opinion. Okay, yeah. Well, we're gonna check like the whys, right? Because well, I'm gonna be bringing like some characteristics, right, or just like fundamentals to explain why, like it's not the future, right, for cloud apps. And when you think about containers, right, let me before like jump into that, you always want like something else, something better, right? Just keep that in mind because well, you want like to run your car, well, Ford Fiesta. I had like a Ford Fiesta, or you prefer like a Ferrari, Lamborghini, right? So, well, I would prefer like the better one, right? So, just before like starting, just like some context. So my name is Marcel Medina. I'm a software developer, been in the market for some time. Yeah, I can say like I'm a practice lead at Datacom. I have some apps created. That's my blog. And I'm currently Microsoft's MVP. This is my QR code if you want just to touch base. I've talked like to some people during like the cafe area, and yeah, just feel free to connect to me. And just bring like the topic, right? So when we look in here, container images, what do we want? Well, like we're thinking about containers, like or images first. We want them to be small. Well, the smaller the better, so you can do pull requests. The pulling of those images like much faster, right? You don't want like to have large images. You want those images to be like secure as well. So you have like less things like in there. Like we're probably gonna have like likely to have the runtime only, no shells, no package manager, nothing additional, right? Just to minimize any sort of vulnerabilities. You want also like to be compliant. So when I say compliant, it kind of aligns like with vulnerabilities because you want the images, you want to have better control over your images. You don't want like your image to have like lots of hashes, a lot of layers in there. And then you find out that there's a particular layer in there that's not compliant, right? Because you're doing like checks of vulnerabilities, for example. You want to, or images like those to be composable as well, because, well, you want to be able to stamp like your changes on top of that, right? So you want to bring like only what's important for you. You want them to be compatible. So if like there are any sort of OS underlying libraries that you want to leverage, well, you're gonna pick like one that's compatible to all your needs. They need to be supported, right? So you're going to rely on the tech giants just like for your images, right? You don't want to make that up. You want like just to take those that are available and supported by the community, tech giants, so you're in a better place. So that's like when you look at containers, images, that's what we want, right? We want like the best. So when you look again, right? So general purpose container images are not the future. I would say, yeah, they're not, because if you have like something where it's inflated, all like full of a lot of packages, a lot of layers in there, well, that's not what's like you can see like in the market, right? Google like started like years and years ago, like the distro-less sort of images, right? The repository where you basically have the runtime, the minimal really just to get your containers to run, right? This statement here, I bring it from the .NET team. I'm a .NET developer. So what I'm gonna bring in here is just some insights of what the the .NET team learnings are around container images. I'm gonna bring some features in there, like if you're not a .NET developer, I think I would just like to bring that you're gonna see the difference, right? When you have like large size images and when you have like something that's very streamlined, right? That was like an update from the product team. So basically they have identified everything that I showed before, where like images should be like small, right? So you can pull like it much faster. Secure, if you can run like no root, a rootless execution, perfect. No shell, no package manager. So you don't have like those kind of concerns around security. Compliant, minimal dependencies, right? So you have easy audits. If you run like CVE, like a common vulnerability explorer sort of tooling, so you can be compliant by minimizing the sort of dependencies. You want to be composable, right? You can add like, this is just an example, localization or anything you need. Microsoft also like mentioned about like different libraries, the OS libraries around glibc or muzzlelibc. So it depends like on your needs, you're gonna factor one over the other, right? Supported right? So you need to have like some sort of community support or a tech giant like Microsoft to help on that. When we look at like the container size improvements around like the Ubuntu images that comes like the .NET, right? So where like now you have like plenty of options, right? Image sizes in here, you can see this one from 86 mega compressed up to 8 mega under the other line. It's just like you have options, right? That's what I want to bring here. There are different characteristics, trade-offs for every single one, but you can see that things are, you have like different flavors, right? So that's basically what comes like the new .NET 8. And looking here at the containers, this used to be the Alpine version for .NET. So you can see different layers where like, okay, you have like Ubuntu, like the size like 28 megabytes. There's like another layer of the runtime, other layers, ESP.NET, the SDK, right? So when you compare now with like the more chiseled, that's how it's been called, the chiseled images, right? So you don't have that sort of, you don't need necessarily an SDK for your apps to run, right? You need the runtime and that's it. With ESP.NET you can. But what has been done is that even like the libraries or the layers, they were decreased, right? Before you look at ESP.NET, 90 to 49. So it's almost like half of like the size. And that's for the chiseled images. For AOT, right, ahead of time, it's just like a new characteristic within .NET, where you basically, I don't know, Java developers, you have like basically on Java, .NET, you have like the intermediate language, and then it kind of packages everything all together, right? When we're looking here, is that like with AOT, you don't have like dynamic resolution, or I would say resolution, resolving of references. It's simply everything is just packs in there. But you can see that the layer of like runtime is much thinner. Well, enough of talk. Yeah, I'm gonna show like some hands-on. And basically we're going to explore with the .NET how the images were resized, right? And the characteristics within .NET 8. Let me just change that. I think that's the other side. There we go. Let me bring across. Actually, let me double this because otherwise I'm gonna be watching this screen. Let me duplicate. All right, cool. So hopefully you guys can see it well. I think that's better, right? So that's just an example, right? So I have, if you go like on .NET and do like .NET New, you can create like new apps like that. You just need to specify the name. That's basically what I did in here. But what it kind of creates for you is just, okay, I'm creating a console app. For the context, it's just like as an example, right? But it's just saying, okay, hello, runtime, the description, in runtime, the OS architecture. That's it, just like 2 lines of code. But the magic happens in here on the project. Let me pull it full screen. Okay, cool. You're gonna see here like we have like some properties here commented out. But, well, even here, you're not seeing like a Docker file. There's no Docker file. How come? So what happens is that I have this Microsoft.NET build containers. It's kind of a library that came up recently with .NET 8. And that's, no, actually no, on .NET 7, right? So there are like improvements on that. This one came like last version. So you don't need Docker files anymore, like on .NET space at least. In here, you're gonna see that, okay, I'm creating like my images in different ways. I can trim I can specify the container family, which is basically the group of like where my container, well, let's say the image names are. They're called like gem chisel, right? So everything now is towards chiseling in, well, let's say the images. I have like other tags around the publish AOT, or I can specify the container base name, container base image. So you have like different options in here, and all of those properties kind of generates behind the scenes a Docker file that kind of is leveraged to create the images with Docker. I'm going to use Docker, could be anything, Podman or whatever, but we're going to do Docker in here. And for example, if I grab, like, I have my cheat sheet in here, so you don't need to, I don't need to type anything. Otherwise, I'm going to make mistakes. Right? I have like this image in here. It's going to be created. And it's leveraging this, the standard. I have not specified any sort of baseline, any sort of base image. So we came up with this Microsoft.NET Runtime 8, and that's the standard, that's the default, right? If I look like the images, right? So you're gonna see that the size of that, okay, it's 193 mega, very large, right? So that's like the first one. And well, can we get better than that? Of course, like, so this one, it contains everything, really. So if I get to do, like, for example, let's put like this one. I'm gonna do first, right? Let me put, so you need to see this first. Because like I'm running things, and by default, well, I'm running this on this Linux VM. So this is Ubuntu, right? That's not my image. It's just like my environment. But if I come in here, for example, and all right, let me put it differently. Let me grab this one first. And so you're gonna see like the baseline has changed. Well, this is one is Debian, right? So the new .NET 8 leverage Debian as default. Maybe like you have preferences, maybe like the libraries that you're depending on, like the underlying operational system. Yeah, that's what you need, but by default it comes with Debian. When we get to chisel that, then it kind of reverts to Ubuntu. There are like a lot of enhancements around Ubuntu. So Microsoft in the team, I forgot the name of the Ubuntu owners, but they work like pretty much like all together to get like those images more like optimized. So if I come back now, right? So I think I was on the previous command. Let's see. If I run this from the Docker itself, and I'm just asking, okay, who am I, right? So I just want to identify, like, okay, I don't have like the context of root in general you're gonna get. You have like now app. So that's a rootless execution, right? So you basically don't have the same sort of privileges as the root. So that's like by default. So that comes in there like with the new images on .NET. And if I am to do a little bit more, like, so I could do like maybe list what's in there, right? So that's what I have inside of the file. I could try deleting that like that, the files, right? So let's see if that's gonna allow me. hello.net.dll. I can't remove, like, my permission is denied. So I'm not a root. I can't do much. So whatever happens in there, if the image is the container is compromised, well, they can't do much. So they don't have permissions because it's rootless. And one of the things as well, that's an additional thing, but in here I'm showing like a console. But if I am to run, for example, ESP.NET, a web app, right? You're gonna see here that by default the port number is 8080. Not sure if you're familiar with .NET or not, but before it used to be port 80. So now it has changed, right? So that also kind of defers any sort of attempts to connect to the container, like if people don't know really, although like they can try different ways, but port 80 is no longer. And okay, so we have like the images created. Now I want like just, okay, get things better really. So what's the difference like with the published streamed I'm gonna get? Because, well, there should be a difference. And if I go back in here, for example, not the publish, yeah, the container, let me just grab and change the tag because otherwise it's gonna get confusing. So I'm just saying that this one is trimmed now. Okay, so I'm gonna generate the image. You're gonna see that saying optimizing assemblies. Okay, so what's the difference in the end? It used by, I didn't specify the image, but now it used different from before, was just runtime. This one is runtime depths. What's the difference? So this is a much smaller sort of dependency that you have as a base image. So if I am now to get this to run, let me put it in here. This one is specifically, let me see. Okay, first, let's compare the sizing. All right, so this one now it's streamed. Okay, and if I look in here, the size, so now we have less. Okay, well, that's 50 mega. Well, that's a big gain, right? So we can make like, can we make like even better? Oh, of course we can. So if we come in here, for example, and I'm gonna chisel that one, okay, and save that. And let me put like this one is going to be the chiseled. So it's doing similar things, optimizing. And what's the size I'm gonna get? Well, that should be better, right? So it shows like, okay, now the runtime, the library, the base image that's been leveraged is James Chisel because I have specified in here. So if I look now, wow, that's a big change, right? So more than 100 mega. So what does it mean? Well, there are trade-offs for that. So why like that's big difference? We don't have package manager. We only have like the kind of minimal sort of dependency for the runtime. We don't even have a shell. I can prove that. So if I come in here, for example, so I create like the one with the chiseled tag, right? And if I put in here, who am I? Well, I need to run a bash. So I don't even have a bash in there. So, right, so for the ones online, so it's simple like an error. So I only have my runtime, the minimal sort of libraries to run the application. And that's a big gain, like from 144 that we had before to 36. Can we make it better? We can. And if we come in here, and I'm gonna do this. Okay, and I'm gonna create like another one. And just see like the tags that I have. I think that was very good. Did I save? Yes, I did. So for the AOT, it's showing here like a different, that's generating native code. And well, if we look like at the size again, my mouse, okay. Okay, wow, well, 17, even less. Yeah, can we make it better? We can, but now we're coming like to trade-offs where like even like for the ahead of time, it's something new, right? That came up with .NET 8. There are things that you can do, things that you cannot. That will vary based on our application. But if you are targeting, like, let's say, edge devices, right? That's where you're going to go towards. Ahead of time is the path for that. So what I can do in here, there is a container-based image which is run nightly. So that's very unstable. But kind of contains everything, right? So it's chiseled, it's for ahead of time compilation, and doing like the basic stuff as we have in here, it's gonna work, right? But it's just to show the capabilities, because what you have now, it's very powerful. So let me uncomment that. And I'm gonna create this one just following the tag that I had it. I think like this one I was going to make it up. Let me just check. Oops. Because we can, AOT chiseled. And as soon as we do it, we're going to have like the same sort of, okay, it was created. Now, like you can see that use the base image runtimes, gem chiseled, AOT. Looking here. So now we got like to 10 mega, right? So that's pretty good. Yeah. I think that's the minimal you're going to get. So we basically jumped from 193 by default, if you don't specify anything, to 10 megas, right? So you have options. So that's why general container images are not the future. You're going to be very specific, right? One of the things that we can do as well, that's part of the .NET 8 new updates, right? But what we can do, we can target different architectures. So if I come in here and specify, okay, I want to target ARM 6.4. This is my computer. It's AMD 6.4, right? So it's x64. So I can target other architectures. So just by looking here, so you're gonna see that. Let me see. Yeah, it created. So it created like under ARM 6.4. And if I try running this one, let's see. Actually, let me just go back to that, because then I need to tag differently. ARM 6.4. This. No, I just want to run. Sorry. No, I'm not going to be publishing. But anyways, I just want to see the image in here. Even less, right? So 8 megas. So yeah, you have a like kind of, depending on architecture, you have like a better gains as well. And one of the last updates as well that we had on this new updates is that we can publish to remote registries. What I'm using here is the Azure Container Registry. Let me put like the commands in here. I have this one. I'm gonna just publish to my container registry, and you're gonna see that the tagging, the label in there is just showing like uploading, right? So some magic happening there. And as soon as that is done, if I bring my Azure Container Registry in here and I refresh that, maybe you're gonna see that I didn't have like hello.net, and this is my ARM 6.4, right? So it didn't ask me for credentials at all. It's just because I had logged in before. I wasn't prompted, right? So what happens there, under the hood, you leverage like the Docker logging, while before you didn't have support for that, if you are going to leverage Azure, right? So that's like something that the .NET team worked on. It's pretty good. I think like for me, as I work with .NET, that's sweet. And yeah, I think like with that, let me see if I have like other examples. No, what I could do, for example, just pulling, right? So I have published. If I look like my Docker images, so it's up here. and I can do pooling with that because I have published, right? So that's it. Well, now it became like a little bit bigger, but you can see that I have just pulled for that. And yeah, so we have like updates on .NET 8, right? So this session was more aligned to the .NET stack. I hope like I didn't bore you guys, but like if you are like keen to learn more, right, about that, let me just share the resource where I grabbed this one from, because, and then you can check yourself. So Microsoft has provided like this container workshop where you can learn ways of chiseling your container images, right, the way you need. So it's a good reference. Also, I have created like how you can do those Docker images on .NET without Docker files. I just showed like today, right? But there's like a blog in there. Have a look, yeah, have fun, and enjoy, because container images are, I think containers are the future, right? So yeah, that's it. Thank you.
Questions? I think Daniel, there was one on Teams.
Teams, which was Argo CD and not Glass.
That's for you.
I got an e-shirt from Argo CD. I use both, depending on the cost. Yes.
If you don't got
Yes.
this in here, the answer there, yeah, we can see you now on the camera.
Thanks. Sorry. Yes, so it was basically a customer thing. So kind of like request for Argo CD first. We have also one main customer who does a lot with Flux CD. So I would suggest, if you have time, try both. They have a bit of a different approach. If you like, the GUI of Argo CD, it's pretty powerful. But okay, so Flux CD is better if you want to have it run in a namespace with less permissions. There's some advantages about that with Flux CD, and Argo CD has more features, more powerful, especially with the UI. It's my 5-second take. Yeah.
Online, just chuck them in the chat. We'll ask them. But we'll do the rest.
These lovely gentlemen.
How do you do, for the Argo CD, how do you do multiple environments? Right? Let's say if you have on-prod environment and the prod environment, and they are different Kubernetes cluster, then you would have a single Argo CD deployment, or you would have two Argo CD watching the same repository. And how do you, and generally like used to, for example, Azure DevOps, we push from one environment to another environment. How does that work in GitOps?
I mean, you can do both. You can have an Argo CD somewhere running, managing multiple clusters. You can have multiple Argo CDs running, as you can have an Argo CD per cluster, or you can have like a central Argo CD serving multiple clusters. And then the Argo CD needs to get to the Git repository. So that means you basically change in your Git repository, and then you basically promote to production somehow, which means that you usually have like a main branch going to production and some feature branch going to the other environment. Yeah. Or you can run Argo CD software as a service with a Qt or whatever. There are like 100 ways to do it.
So earlier you showed that you removed the controller and Argo CD recreated. So did you check what happens at the packet level? I guess if someone in the middle of transaction, it kills the process.
So I removed the ingress resource and Argo CD recreated it.
During this time, what happened in the...
That's a good question. That's a good question. So my guess would be this. You have...
You can check that.
No, I didn't check it yet. It's a timing thing. It's a timing thing. So the ingress controller, depending on the ingress controller, needs a certain has probably an event listener, the Kube API, getting informed about the change of an ingress resource. And then I think it's depending on the ingress controller, and it's depending on how fast the ingress controller changes the actual reverse proxy configuration, in this case of an Nginx. So it could be that it drops the HTTP connection, or it could be that it's just too slow to catch up.
About deployment, if you remove a deployment and Argo CD recreate it, so the service won't be available, right? Is it fast enough?
Yeah, with a deployment. So if you delete the deployment, it's terminating. That probably takes a moment. I actually do not know if Argo CD waits till it's terminated, and then yeah, the service will be down for sure. Yeah, probably do it. I have to test it actually. Should test that. Yeah. But it's like a blunt example, deleting stuff. But usually it's more like smaller stuff. But yes, you're absolutely right. Yeah, you're right.
So been trying to optimize startup time. These optimizations in .NET with the startup time.
Yeah, in particular, if you ahead of time. So what happens that if you know like the architecture of .NET is that in general, when it gets compiled, it generates intermediate language. But with ahead of time, what happens, you have intermediate language plus native code combined, right? So you have, if like you have like issues with startup on .NET, that would be the option really for you to leverage on your containers and have much faster startups. Yeah, that's something to have a look in, because there'll be more updates on that. With .NET 8, it just came up like back in November. So there are still libraries that are supported, libraries that are not supported. But yeah, on that like a link I provided, it has all the details about like what's coming up next. Yeah.
Or you fix CVEs if you don't use Docker. You have an image with these CVEs.
Yeah, I think like on this one, well, if you run like any sort of tooling, right, for verifying like the layers in there, and you have not fixed, like you basically, it depends at the level of the layer. Like if it's, let's say if you have 100 layers and like the issue is on layer 50, you simply, well, can you revert back like on your codes on things that you have done? But if that's part of the base image, you're simply screwed, right? Because you cannot like simply remove that unless you go to the tooling and tell to ignore that. But that's a decision you're making, right? That to ignore that particular vulnerability. So I think that's the issue that used to happen before, because those general container images that Microsoft used to leverage, right? They had like issues in because of the base images. So now you have options like, okay, if you don't need 90 dependencies in there, you want like just 6. Well, you can leverage like from that diagram, the different sort of container images and see like what works for you. Yeah.
Argo CD, with the classic CI pipeline, often you have steps after deployment as well. Any good solutions for, I guess, running those in that CI pipeline after the deployment has happened to Argo CD?
Yes, you can still do that. You can still have some kind of verify job, and then you can use the Argo CD CLI and look for some sync status and health status, and then you will get a much more comprehensive status. But yes, it kind of brings Argo CD back into your CI/CD pipeline, because then you have the job changing the Git. Yeah. Then the next job waits for Argo CD to sync and then verify. Yeah, so you're still back fiddling around with timing and making sure that you're not happy before it's actually deployed the new version. And yeah.
Is the CLI tool also using like a public API server?
You can. Yeah, you can. Of course, you can also do kubectl wait or whatever. Yeah, you can use Helm tests, and then they're integrated in the Argo CD status. What I also often see is actually that the traditional CI/CD pipeline triggers an Argo CD sync to the Argo CD CLI, and then it feels like an imperative command, like, hey, do this, and it waits till it's done. Which still enables you to have this kind of GitOps for at least for like having a CI/CD pipeline. But yeah, it gets complicated again. Yes. I have one question for Microsoft.
Yeah.
Is it now that do you still often see like .NET on Windows or Windows containers deployed? It's all Linux first.
Linux.
containers.
Yeah.
Okay.
So we kind of evolved.
We're in a Microsoft building. Amazing. Developers.
Good question. Good question.
I have a question about AWS. No, I'm kidding.
Another round of applause for these two gentlemen.